Alright, so in this class, we are going to be dealing on mathematical induction. If you are just joining us for the very first time, please subscribe to this channel and also like this video. And maybe along the line, if you have a question, endeavor to leave your question in the comment section of this video. Alright, let's consider the definition of mathematical induction. Mathematical induction is simply a method used to show or prove that a mathematical equation or statement is true or correct. So it is simply a method used to show that a mathematical equation is correct. Alright, let's look at the steps involved in mathematical induction. There are three major steps involved in mathematical induction. The first step here is the basic step, where n is equal to 1. For the basic step, you have to substitute n as 1. And then the second step is known as the inductive hypothesis. You have to substitute n as k. And then the last one is the inductive step, where n is equal to k plus 1. Alright, let's solve this question so you would understand better. It says, prove by induction that 1 plus 2 plus 3 plus ... plus n is equal to n multiplied by n plus 1 all divided by 2 for every positive integer n. Alright, let's start with the basic step. We have here the basic what? Step. And for basic step, we have that n is equal to 1. That's for basic step. Alright. So from the question, we have that n is equal to n open bracket n plus 1 divided by 2. Now this is the equation given. Whenever you are given a question, simply neglect this 1 plus 2 plus 3 plus ... So you would only consider n equal to n open bracket n plus 1 all divided by 2. So for the basic step, we will have to substitute n as 1. So if we substitute n as 1, let's consider the left hand side. For the left hand side, we only have n here. So for the left hand side, for the left hand side, we only have n. So if we substitute n as 1, so we will have 1. That's for the left hand side. Now let's consider the right hand side. The what? Right hand side. For the right hand side of the equation, we have that n open bracket n plus 1 all divided by 2. N open bracket n plus 1 all divided by what? All divided by 2. So if we substitute into this equation, remember we are substituting n as 1. So we have 1 open bracket 1 plus 1 all divided by what? 2. So this gives us 1 plus 1 is 2. So we have 1 multiplied by 2 divided by 2. 1 multiplied by 2 is what? 1 multiplied by 2 is 2. So we have 2 all over 2. And 2 all over 2 is equal to what? It is equal to 1. So this is for the basic step. All right, let's consider the inductive hypothesis. Inductive hypothesis. For the inductive hypothesis, N is equal to what? K. For inductive hypothesis, N is equal to K. Now remember that N is equal to N open bracket N plus 1 divided by 2. So if we substitute N as K into this equation, we would have K is equal to K open bracket K plus 1 all over 2. All right, so let's call this equation 1. Let's call this equation 1. All right, let's consider the third step, which is inductive step. In inductive step, N is equal to K plus 1. That's for inductive step. Now let's substitute into the equation. Remember that N is equal to N open bracket N plus 1 all over 2. This is the equation given in the question. All right, so let's call this equation 2. Now take note of this. Before you start substituting into equation 2, kindly write down the left-hand side of equation 1 and add it to the left-hand side of equation 2. Let's check equation 1 again. All right, so this is equation 1. For the left-hand side of equation 1, we have that 1 plus 2 plus 3 plus dot k is equal to k open bracket k plus 1 close bracket all divided by 2. So the left hand side of equation 1 is this. So this is the left hand side of what? Equation 1. This is the left hand side of equation 1. So we are going to add this left hand side of equation 1 to the left hand side of equation 2. So we have here 1 plus 2 plus 3 plus dot plus k. This is the left hand side of equation 1. And then we will have to add it to the left hand side of equation 2. So we have plus what? Plus n is equal to what? Is equal to the right hand side of equation 2. So it is equal to n open bracket n plus 1 all divided by 2. All right, so at this point, we can now substitute n as k plus 1. Remember that for inductive step, n is equal to k plus 1. So wherever we see n, we write k plus 1. So we have here 1 plus 2 plus 3 plus dot plus k. Plus n is k plus what? 1 is equal to n is also k plus 1 multiplied by let's use this kind of bracket. So we have k plus 1 plus what? Plus 1. So we close the bracket. This is called square bracket. All divided by what? All divided by 2. So we are done substituting n as k plus 1. Now, recall that 1 plus 2 plus 3 plus ... plus k from equation 1. Okay, now recall that 1 plus 2 plus 3 plus ... plus k is equal to k open bracket k plus 1 all divided by 2. So wherever we see 1 plus 2 plus 3 plus ... plus k, we are going to substitute k open bracket k plus 1 all divided by 2. So instead of 1 plus 2 plus 3 plus ... plus k, we are going to substitute k open bracket k plus 1 all divided by what? All divided by 2. This is coming from equation 1. So we have here plus k plus 1. So we have plus k plus what? 1. Let me erase this because there's no space. Let me erase it. All right, so we have here k open bracket k plus 1 all divided by what? All divided by 2 plus k plus what? 1. And this is the k plus 1. It is equal to what? It is equal to k plus 1 multiplied by what? So it's equal to open bracket k plus 1 multiplied by, we have here k plus 1 and then plus 1. Now let me erase this one and write it well. So we have here plus 1. Then you close the square bracket. And then all over 2. Let's confirm it if it aligns with the one we have. We have a k plus 1, k plus 1, and then everything inside the square bracket divided by 2. All right, so let's simplify further. For the left hand side, let's simplify further. We have that k open bracket k plus 1 divided by 2 plus k plus 1. Now take note of this. Whenever you have 5 divided by 2 and then plus 4 divided by 3, you will have to take the LCM. If you take LCM here, you would have 2 multiplied by 3, which is denominator, is 6. So our denominator becomes 6. Now 2 into 6 is 3, which is this. 3 will multiply the numerator here, which is 5. So we have 3 multiply 5. And then plus these 2 will multiply 4. So we have 2 multiplied by what? 4. So that's how you get your LCM. Now let's apply this for the question given. If we take the LCM of k multiplied by k plus 1 all divided by 2 plus k plus 1, let's say this is divided by 1. Normally it is divided by 1. So if you take the LCM here, we will have this. So we have here, what's the denominator? 2 and 1. So 2 will multiply 1. So we have here 2 as the denominator. Okay, from the concept I explained earlier, you will have that 1 will multiply the numerator for 2. So we have 1 multiply, what's the numerator for 2? It is k, open bracket, k plus 1, then close bracket, and then plus 2 here will multiply the numerator for 1. So we have here 2 multiply k plus what? 1. So it is equal to, what do we have at the right hand side? We will just write down what we have at the right hand side again. So we have here k plus 1 and then multiply by k plus 1 and then plus 1. All divided by what? All divided by 2. So at this point, we are going to open up the bracket. So now let's open up the bracket. K open bracket, k plus 1 and then plus 2k plus 2 divided by 2 is equal to k plus 1 open bracket, k plus 1 and then plus what? K plus 1 all over 2. So we've now opened the bracket. So we are still going to simplify further. We open up the bracket again. K multiplied by k is what? K multiplied by k is k raised to power 2 plus k multiplied by 1 is what? Is k plus 2k and then plus what? 2 all over what? All over 2 is equal to k plus 1 multiplied by k plus 1. If you multiply this, it will give you k square plus k plus k and then plus 1. Alright, so if you don't know how to multiply this, let me show you. You will use each of the terms in the first bracket to multiply all the terms in the second bracket. So k will multiply k plus 1 and then 1 will also multiply k plus 1. And then we have here plus k plus 1. So we write here plus k plus 1 all divided by 2. So at this point, we are going to collect like terms. So if we collect like terms, we have that k raised to power 2 plus k plus 2k is 3k plus 2 all divided by what? All divided by 2 is equal to, we have here k square. k raised to the power 2 plus k plus k plus k is 3k. So we have here 3k plus what? 1 plus 1 is 2. So we have 2. All divided by 2. So if you check very well, we have for the left hand side k square plus 3k plus 2 divided by 2. And for the right hand side, we have k square plus 3k plus 2 divided by 2. If you check very well, the left hand side is equal to the right hand side. So therefore, the mathematical statement is correct. The mathematical statement is correct.